Hey buddies, welcome into the paper 1 touch-ups, which is the things that you need to know as you're about to write the final exam, which is paper 1. Now in this video we'll be looking into simple, compound, effective and nominal interest. So I'll be basically showing you the formulas and what they mean and how to actually use them, right? So if you're new to the channel, please be sure that you subscribe so that you won't miss when another video gets uploaded. So without further ado, we're gonna go straight into the next slide. Now here in the next slide, I have some formulas here, which is the things that you need to know. Now here, the formula that you need to know here that I'll advise you that you remember is this one, the first one here. So this one is the effective and nominal interest. This one, the reason why I'm saying is the one that you need to remember or to memorize is because it is not at the back of the formula sheet. Now here in this formula, you can see that IEFF is the effective interest and I norm is the nominal interest, and then M here is called a compound. Now if you're wondering what is a compound it's when you have a question, and then in that question you'll notice something that say the interest is compounded semi-annually, right? Semi-annually. So when that interest is compounded semi-annually, it means now M becomes 2, right? Sometimes you will get it as quarterly. And this means M is going to be 4. And then in most cases they like to say monthly. So this then means now here M is 12. Now this M works very well, or this M is always mentioned when we're talking about future and present value. And also in these type of formulas it is also used, but I will show you how they're using it here. So now, like I said, this is the only formula that you need to understand. And then here in the accumulation, we can see this is the formula that we have at the back. That is a compound interest. This one's a simple interest. And then when we're talking about depreciation, we have this simple depreciation and that compound depreciation. Now another thing that I want to mention here is the value for P, for A, and I, and N, right? A, I, and N, right? Now here P is the value before, which is the value that we are given before, and then A becomes a value after. Then now here N, please make sure that in this time you stop looking at N as a number of years, because N is not a number of years when you're talking about simple interest or when you talk about accumulation and depreciation. N here is the number of times the interest is added. Now in the future value and the present value, it becomes the number of times the deposit was made or the payment was made, right? But we want to discuss that also later in the next video. And then here I, right, is the interest. Now N, to calculate N, what you need to do is you always need to have your number of years, right? And then you need to multiply that by your compound. What about an interest? An interest you will always be given per annum, right? You always notice that it's going to be in per annum. But now what you need to do is, if they said per annum compounded quarterly, then it means you need to take that interest and divide it by M. Now here we know that our interest, right, you were told that you can basically take the interest. For example, if I is 5%, we were told that what we need to do in the formulas is to take for I and then divide it by 100, right? But now my advice is, in your calculators, a calculator can press this, right? So my advice now is don't use 5 over 100, because it's going to confuse you when you're doing future values. Rather press this as in a percentage, right? So how do you do that in your calculator? In your calculator, you notice that there's this button that has a open bracket, right? So that button that is an open bracket, you'll see that at the top of it there is a percentage there, right? In a color, I think it's gold. That percentage, if you want to press that, you're going to first press shift, right? And then you're going to press the bracket. So when you do that, it's going to give you the percentage. So if you want to say 5%, so you're going to press that, you're going to press 5%, and then if you put an equal sign, it will give you straight 5 over 100, right? Okay, so now that we got that out of the picture, let's go ahead and look into the type of question that we'll be looking into, and also be explaining how you're going to be using these formulas, right? All right. Now in the first question, basically here I'll be showing you how you can spot if a question is a compound, or is it depreciation, or is it nominal interest, right? Okay, so let's look into this question here. Now the question goes as follows: how many months will it take for an investment of 5,000 to grow into 6,522.25 in an account that earns compound interest of 8% per annum compounded monthly? Now here, what is it that we're given here? So here we want to calculate the number of months, right, that will take for an investment of 5,000, right? So it means for a value that started in 5,000. Now if you remember in the formulas, we said that a value before, right, it is P. So now here the value here before, it is what? 5,000. So which means P here is 5,000, and then that value grew into 6,522.25. So this then means now the value now after, which is A, it is 6,522.25, right? So now here this value, it did what? It grew. So because of it grew, this means now this is going to be a what? A compound interest, because this is also what? An investment. So the keyword here is the word investment, and basically the interest, it is compound interest. So now here we can see that this then means now our I, right, it is going to be 8%. Now remember, it is per annum, but it's compounded monthly. So if it's compounded monthly, we know that a compound that is monthly, that's when m is what? Is 12. This then means now I, we're going to divide it by what? By 12. So the question says how many months will it take for that to grow? So which means now what we're going to do, we're going to go to our formula. A is P into 1 plus I to n. Then now here we're going to calculate what? We're going to calculate n, which is the number of months. So now before we can calculate n, here's another advice that I would like to give you. So here, I know that you were told that whenever you're using the formula, the first thing that you need to do is to substitute. Now here I know that it's what we're told, but now my advice is, most cases people, they tend to make mistakes by simplifying or rounding up into 2 decimal before the final answer. So my advice here is, if you wanna get the correct answer, the first thing that you need to do is you need to isolate what you're trying to solve. So here we're trying to solve for what? We're trying to solve for n. So this means we need to first isolate n, and then after isolating n, we need to do what? We need to then substitute everything on the calculator. Now how do we do this? So the first thing that I need to do is I need to take P and divide both sides, right? So this eliminates P there, and then here I'll know that I'll be left with 1 plus I to the power n, and then here I'll be left with A to the power A over P, sorry. All right, now here I want to solve for n. Now n here is what? N is a power, right? It's an exponent. So now I can see this is an exponent. So if this is an exponent, this one, it means it's going to be what? A base, right? So this one, you can just call it a constant, or you can call it a solution, right? The answer to get. So now I know that in a base and an exponent, which is an exponent, I know that its inverse is what? It is a log. So now, which means now if I want to solve for this n, I will say n is equals to log base, right? Base and constant. Now what is my base? My base, I know it is log, it is 1 plus I, right? And then I know the constant that I have here, it is A over P, and this gives me my value for n. So now that I have isolated the value here, what I'm going to do now is substitute. So when I'm substituting, this is how I'm going to do it. So I said 1 plus, remember I said it's 8% over 12, so you can just write this as 8% over 12 in your calculator, right? Now what about A? A is 6,522.25, and then P, it is 5,000, right? Now When you press this on your calculator, you're gonna get 39,999, right? So if you can, as you can see here, this basically is 40, and that is going to be the number of the payments. So let's go ahead and look into another question. Now the second question reads as follows: a vehicle depreciates by a third of its value in 10 years according to the diminishing balance method. Calculate the rate of depreciation and leave your answer as a percentage. All right. Okay, so here first things first, we need to identify what type of a question is this. So now here we're told that a vehicle, that is the price of a vehicle, depreciates, right? As you can see here, the word depreciates, so which means here now we're going to use what? A depreciation. So now they said the price of the car, the price that it had before, depreciated by a third of its value, right? So what does this mean? So let's say the price before, the value before P, it was, let's make this value to be X, right? Now, if the price of the vehicle depreciates by a third of its original value, it means now this new price of the car is going to be X, right? Which is the original price minus a third of X, because that's how it depreciated, right? So this basically gives us 2 over 3x. So basically A is 2 over 3x. Now here we are told that this happened in 10 years. So this then means now here we don't have a compounded monthly, we don't have a compound, we just have 10 years. So it means now N is straight 10. Now the question here, it says this calculate the rate of depreciation. So because of we're talking about depreciation, when I use the formula A equals to P into 1 minus I to the power N, right? Now here we want to find what? We want to calculate I. So now which means before we calculate I, what we need to do, we need to isolate. So let's go ahead and do that. First things first, we're going to divide by P both sides, cancel out, and then A over P becomes 1 minus I to the power N. So now I want to have I, which is I want to have what's inside here. So to do that, I'm going to take an nth root both sides, right? So the reason why I'm taking an n root is because it's in this bracket is all to the power of n. So I know that if this was 2, or if this was something in bracket all squared, I was going to say square root. If it was a cube, it was going to say cube root, but now it's n, hence I'm saying nth root, and then that's going to cancel with this, and then in this side I'm going to be left with 1 minus I, and then on that side, actually let me just move it down here, 1 minus I, that side I'm going to be left with the n root of A over P, and then from here I'll take the I and move it across, and then take the nth root of A over P and move it across. Then it's going to be 1 minus nth root of A over P. Now I've isolated my interest, so let me calculate now my value for the interest. So I'm going to substitute my values, 1 minus, now I know what is n is 10. Now what is my value of A is 2 over 3x, 2 over 3x divide what is my old value, it was x, right? Okay, let me just do this. All right, now this cancels with this, and then now what do I have here? So now I have I equals to 1 minus 10th root of 2 over 3, right? Then now let's press this in your calculator. So when you press this on your calculator, you're gonna get 0,039735. Let me just take these ones here, and then you multiply this by 100, because remember I need to leave it in a percentage. So I becomes what? Becomes 3,97%. Right, I hope this made sense. Now let's go ahead and look into the final one of the simple, compound, and nominal interest. Now this one it says convert a nominal interest rate of 7.5% per annum compounded quarterly to an effective annual interest rate. Now leave your answer as a percentage. Now as you can see here, this one, it tells itself that here we're going to be working with the nominal interest and the effective interest. So what is it that we're given here? So here we are given I nominal as 7.5%, right? And then we are told what is a compound. So the compound here is quarterly. They said compounded quarterly, right? Compounded quarterly. So M is 4. We just underline that. All right. And then here they want us to find what? They want us to find IEFF. Now here, please understand that in this formula, the parts of the interest, we don't divide them by the compound. Why? Because here in the formula, if you remember the formula, it is 1 plus I effective, which is equals to 1 plus I norm over M all to the power of M, right? As you can see here, this is already been divided by the nominal, right? Sorry, this has already been divided by the compound, so it means now we cannot divide everything by what? The compound. So M is already here, so we don't need to divide the interest by what? By M. So let's go ahead and isolate I effective first. So I if EFF is going to be 1 plus I norm over M minus 1. So now let's substitute here. 1 plus I norm is what? Is 7.5%. Now don't remember percent, you can press it on your calculator as it is. It's gonna give you the same answer, minus 1. So what happens when you press this on your calculator? You get I effective as 0.07713, right? Multiply this by 100, and this gives me 7.71%. And that is all for this video. I hope this video was helpful, and if you like the video, please make sure that you like it. Please also share a comment so that you can give me some of the ideas if there's anything that you would like to add into what I think that you need to know when you're talking about simple, compound, and effective and nominal interest. And I'm going to leave you into this video. Make sure that you take the notes, and please be sure that you subscribe so that you won't miss when another video gets uploaded. And I'm going to see you on to the next one, where we talk about future values and present values. See you there.